Today I'd like to just do a real quick run through of Arduino programming basics, and therefore just basic programming in Java or C++. First of all, Arduino specific. It starts with two methods. These are methods or functions. This gets called once when you first turn on your project, or when you just upload the code, or anytime you hit the reset button. This happens once first, and then this will happen over and over again afterwards. So in case you're wondering what these are. Now, you don't have to put all your code in there. You can declare variables outside of that if you prefer. In this case, I'm going to create an int variable. So if I want to create an int variable, the most common type of variable, I'm going to say, hey, int x, so variable type, in this case an int, whatever the heck I want to call it, as long as it's when they allowed conventions, all allowed characters and stuff, then you can do that. And then start it out at something. Why don't I start it at 0? I've got a variable, called x, and it's equal to 0. Next, I could make a different type of variable. Let's say I want to hold a something with a decimal point. I could use what's called a double. Double stands for double precision floating point number. You don't need to remember that, but it's just how it's represented in memory. So this type of variable can handle anything with a decimal point. And another common one is called bool in C++ or Arduino, boolean in Java, and I could be like boolean is awesome, and make that equal to true. So this can only be true or false. Something to note about C++ and Arduino, they consider any number that's not 0 to be true and 0 to be false. So by the way, anytime you see high, that's just the same as 1. And anytime you see low, that's the same as 0, also false. High being 1 is also true. So all those things are equivalent. So occasionally useful. You can make things a little shorter if you want, if you understand that. Now, let's talk about scope. So I've created these three variables. I've got an int, a double, a bool. Notice they all follow the same pattern. Type of variable, whatever the heck I want to call it, one equal sign, and then what I want to start it at, and we end every complete IDL line with a semicolon. So notice these are all basically the same idea. Now, what if I wanted to, instead of putting this here, what if I put it right here? And then I tried to do x now equals 5. So I want to change the value of x. So I declare it in setup, and I want to use it in loop, and I go to run it, and it'll be like, oh, geez, x is not declared in this scope. It's like, hey, x doesn't exist here. Why are you trying to set something to 5 that doesn't exist? And the reason for that is you got this idea called scope. Things only exist inside the curly brackets they're created in. If I move this, oops, stop it. All right, now if I were to switch it back here, from here, this is not inside curly brackets. Anytime you see me declare stuff at the top, it's because I want it to stay in scope the whole time. So if I were to start the simulation now, it'll have no trouble. Notice no errors, no problems, it's all good. Because x does exist here if I declare it up here. I say, hey, I want to make an int type of variable. I'm going to call it x, and I'm going to start it at 5, and then I can just mess with x later once I've initialized it, once I said what type of variable x is. But benefit to that over this, because this will also work. This does not cause any trouble. So notice no problems. Problem with this is, let's say I want x to go up. Here's a bit more of a complicated one. I'm just going to get it so I can print stuff out. Remember, sealed up again lets you talk between the Arduino and the computer. Say declare X here and go X plus plus serial dot print line X. So I'm going to print out the value of it. I declare the variable, make it go up by 1, and then print it out. And then I'll delay a bit just so it doesn't go crazy. Let's say every half second. If I run this, you'd think it would just go up and up and up and up. The problem is this code runs over and over and over and over again, and every time it hits the end bracket, X ceases to exist. And then we go create it and start it over again each pass through. So when we run this, we're just going to see a lot of ones. So we started at 0 every time, and notice, yeah, we're just creating a lot of ones. It's just printing out. Whereas the only thing I need to do differently to get it so it will actually count up is if I declare it up here, still in scope, but it persists between loops. So if I do this, we should see 1, 2, 3, 4, 5, 6, 7, 8. So you notice that's more typically the sort of behavior you want. So there's often a lot of benefit to declaring things up top. Now, one thing you might be asking yourself, what the heck is this? This is one way of modifying a variable to make it 1 bigger than it was before. Some other ways to mess with variables are I can use normal math. I can say, hey, X equals what it was before plus 5. By the way, my mathematical operators are a plus sign, a minus sign, multiplication, which is the star, division, which is the slash. We also have this funny little thing, the percent symbol, which is mod, which gives you the remainder when you divide the thing in front of it after, just for example. If I do 5 divided by 2, and I'm finding the remainder, this is equal to 1. Because if I divide 5 by 2, I can make 2 groups of 2, but then I'll have one left over. And this gives me how many leftover bits I've got after I make groups of 2. If I did, I don't know, 7 mod 5, I'd have the remainder after I made groups of 5. So I started with 7 things, I'm making groups of 5, I'll have 2 things left over. So the computer will read this as just the number 2, just in case you're wondering. All right, so this line right here, it makes X5 bigger than it was before. This makes X 3 less than it was before, the line before. This makes X equal to what it was before times 2. Apologies. So X would be 2 times what it was before there. And this would make X a third of what it was before. You can also do stuff with mod if you prefer, but I will start with basics. So this is a basic way to mess with stuff. I can get fancier. I could be like, make X equal to 2 times what it was before plus 5. And it'll obey bedmass rules, order of operations. So brackets, exponents, and then multiplication, division, and addition, subtraction. If you put it in, you can do a big like whatever the heck you want in here. Common shortcuts. Here's the equivalent way of doing the thing above. Here's the shortcut way. Plus equals 5. So this line and this line do exactly the same thing. And there's equivalent stuff for all these guys too. I can say, hey, X minus equals 3. And now x is 3 less than it was before, just like this. This line and this line do exactly the same thing. Another thing here, by the way, 1 equals sign makes it true. It's kind of weird because it doesn't look like math, but this is saying, hey, make x, the x variable, equal to what it was before plus 5. You'll always only have one thing before the equal sign, barring stuff like this if you're factoring in the type of variable you're making. But you're saying, hey, the one thing to the left, make it equal to what comes on the right. That is always the way and not reversible. If I want to make x double what it was before, here's the shortcut for that. Times equals 2. And here's the shortcut for this line right here. Make x equal to, or divided equals 3. So these lines are all equivalent. So hopefully they make a bit of sense. There's also 2 other shortcuts, which are good to know. This would make x 1 bigger than it was before, and this would make x 1 smaller than it was before. Yeah, I just changed the value. So you can do a bunch of math. More important than you think, every score in a game you've got, when your score goes up or your health goes down or your damage for a weapon, they're all variables and they can go up and down and change in whatever way you want. Like let's say you're at double bonus point score, you might be doing something like this, or you beat an enemy with 5 experience points. Your experience points have gone up by 5. So there's all kinds of junk like this going on in the background all the time. You want to update the position of your player character. Take their one coordinate position and increase it by 5. Like that's how far you've moved in the world in the time delay between one frame and the next. Stuff like that. So all this stuff is all over the place and cooler than you think. So we talked about scope. We should talk about conditions. Because a big part of why you would use this stuff is for the idea of conditions. So a condition is just something that ends up being either true or false. And we do a lot of this mathematically. So some numerical true-false things like operators we can use to compare things is we can use equals equals, that checks if two numbers are equal. We could do does not equal, because the exclamation point means not. So that just checks that the thing on the left is not equal to the thing on the right, and then that's a true statement if so, if they're not equal to each other. You can say, hey, the thing on the left is greater than the thing on the right. You can say the thing on the left is less than the thing on the right. And sometimes you want to do, hey, the thing on the left is greater than or equal to the thing on the right. Or you might want to say, hey, the thing on the left is less than or equal to the thing on the right. So some examples of this might be like 3 is less than 5. That's a true statement. The computer would look at this and see that as just being true. If it could say like 2 is equal to 2. That's another true statement. Whereas this would be a false statement. 2 does not equal 1. You could say 3, how about this? 6 does not equal 7. That's a true statement. 6 is not equal to 7, so that evaluates to true. You could say, hey, 5 is greater than 6. That's a false statement. 5 is not greater than 6. You could do 5 is less than 6. That would be a true statement. You could say 5 is less than or equal to 5. That's a true statement. Or greater than or equal to 5. Because they're equal. And you can say 6 is less than or equal to, let's say 3. That would be a false statement, so that would evaluate to false. And there's different ways you can chain these guys together. You can chain them together with and if you have two things chained together with an and, that means they both have to be true for the whole thing to be true. You can use this guy, two vertical lines. That means or. That means for the whole thing to be true, both things have to be true. By the way, with both of these, if you're going to use them, you need two full true-false ideas on either side of them. So I could pick one. I could be like, hey, here's one true-false statement, and I could throw in like an and then here's another true-false statement. So this is a false statement, and this is a false statement. So the whole thing would be false. If I make one of them true, this is true, and this is false because 6 is not less than or equal to 3. So the whole thing would be false because with an and, things on both sides have to be true. If I did this, though, the whole thing is true because this is a true statement, and this is a true statement. Now, if we switch this to an or, then only one of them has to be true. So this, like if they're both true, rock on, the whole thing's true. But if you make one of them false, say 8 is not less than or equal to 7, it's still true because only one of them has to be true. Just like I told you, I'm your teacher or the King of England. One of those things is true, so my whole statement is true. I have not lied to you. But if I told you something false like I'm the King of England or I'm the richest man in the world, both those not true, so the whole thing is not true. That's the only way you can get false with or, is if they're both untrue. Now, you are probably never going to use any of this like this. You're going to combine it with variables. So you might be like, x is less than 5, or like score equals 1, or health does not equal 7, or whatever. So, but they're equivalent. When the computer sees these variables, it doesn't see it as like a word. It sees it as its value. So maybe x is 3. So when you do x is less than 5, it sees that as 3 is less than 5 and that the whole thing is true. When you do score equals 1, it doesn't see that as like some word is equal to 1. It sees it as whatever score's value is. So it might be like, oh, your score is 2. This is a false statement. Your score is not equal to 1. Your score is equal to 2. And so on. So when you see it, it'll look more like this, but it's exactly the same idea under the hood. So like think through that. These things are just ways of representing numbers, typically in this case. By the way, with some of our setups here, one thing you might see fairly frequently is it might not be 0. Since we're working with Arduino, we might be doing analog read. So the computer sees this. This is just a number based on the voltage at pin A0 on your Arduino. So it's a number between 0 and 1023. So it might, let's say it reads it and it gives a number of 510. So this is just int x equals 510. It doesn't see this as something fancy. It sees it at what it's equal to, which is a number based on what the voltage is at pin A0. So just be aware of that. Anytime you're like, oh, my int for my potentiometer is equal to analog read A0, this is just going to be a number, and we're just setting our little int pot value to equal that. The whole reason we want to do this is so we can use them in like if statements and for statements and while statements and junk like that. All an if statement is you got the word if, you got some smooth brackets around your condition, and some brackets to hold whatever the heck you want to do if this condition is true. That's it. So this should be your structure every time, and just mix and match, throw in whatever condition you need at the time. So 5 is greater than 6 or 8 is less than 7. Yeah, they're both false. So yeah, if this happens to be true, which in this case it's not, but let's change it so it is. And so now it's true. Only one of them had to be true to make the whole thing true. In fact, this is also still true. So do whatever's in these brackets, whether it's printing something or changing a variable or whatever. One thing that's been coming up a lot recently is toggling between LEDs. So you've got some LED called pin or whatever, starting at the first pin you want to mess with, say 9, say it's 9, 10, and 11, the pins you want to toggle between for your red or green and blue LEDs. You'd say, hey, if pin is greater than 11, you want to reset it back to 9 because you're always increasing it by 1. So you could just be like pin equals 9. So that's kind of a common thing that has come up recently when having a button pressed to change between lights you're using. You want to reset it if you're going out of bounds. So if you go out of bounds, if you've got LEDs connected to pins 9, 10, and 11, if you press the button and it just increases the value of pin by 1, and it puts it to 12, then you want to reset it back to 9. So you're not trying to light an LED that's not there. So that's a very common kind of thing. Keep in mind you can do all kinds of other stuff, like the computer sees like digital read. That's just equal to high or low. Let's say you've got a button on pin 2. If that goes to low, because you've got it set up in some form where when you press the button it goes to ground, then this would work lovely. So it would just read this as high or low depending on what the voltage is at that pin 2 when it hits this line of code. And if that's also equal to low, I would set pin to 9. So that's a common if statement. If I want to change it to a while, I could be like, well, the button's pressed. The only difference between this and an if statement is with an if statement, it will check this once right when your code hits this line, and then do this once, and then never again. But with the while loop, the only difference is when you hit the end bracket, it'll then go check your condition, and if it's still true, it'll just start executing what's in the curly brackets again. So do it again. Another thing that happens with ifs is you can have else ifs. You just do an else. So this means, hey, if you're pressing this button, if this condition is true, whatever it is, we'll set the pin to 9. Else, if this condition is not true, we'll set the pin to 6. Or maybe we want else if the button's not being pressed, but maybe there's a second button on pin 3, so we could be like digital read 3 is equal to low. Then we want to set pin to 6, but if neither of those is true, we're going to set pin to 4. So now we've got it. So if the pin connected to button 2, they'll check that first. If that's being pressed, if its voltage is 0 volts at that pin, it'll set pin to 9. Else if, it'll only bother checking this if this was false. So both of them can't happen. You won't set it to pin 9 and then set it to pin 6. It'll just be one of the two. So if this is false, it'll go check this. It'll check your button connected to pin 3. If that's being pressed and at 0 volts, it'll set pin to 6. And if neither button is being pressed, it'll set pin to 4. It's kind of your standard if statement. And it uses these conditions. Maybe I want to throw in an and here. If the button is pressed and the state of X is greater than 5. Maybe this button only works if X has hit a number greater than 5, and otherwise we want to ignore it. Now, both of these have to be true for the whole thing to be true, so pin is only going to 9 if the button is pressed and X is greater than 5. All right, last thing I want to mention, for loops. For loops have like 3 compartments. And it just keeps looping it again, like a while loop. Your first compartment, typically you're creating a variable. Notice there's only 2 semicolons. They separate out the 3 compartments. So we got variable making. We got our condition, just like we'd have anywhere else. And then we have usually messing with our variable, changing our variable when we hit the end bracket. So what that looks like in practice is, let's say we create a variable called I and start it at 0. And then we want to keep going while I is less than 5. And every time we hit the end bracket, we want I to go up by 1. This is a loop that'll execute 5 times, once when I is 0, once when it's 2, once when it's 3, once when it's 4, once when it's 5. Just is, it'll do this thing first. It'll create this variable called I that stays in scope only until the for loop is done. Starts it at 0. It'll check this condition is true. 0 is less than 5, so it is. So it'll go do whatever's in the brackets, do whatever's in there, hit the end bracket. It'll do this thing first, the changing variable bit. I will become 1. It'll then check the condition again. 1 is less than 5, that's true, so it'll do whatever's in the brackets here. Hit the end bracket, and then it'll do the changing the variable part. So now I would be 2. Check that 2 is less than 5, which it is, so it'd go do whatever's in the brackets again, hit the end bracket, do the changing the variable thing again. I would now be 3. It would then check the condition again. 3 is less than 5, so it'd go do with the junk in the brackets again. Hit the end bracket, go do the changing the variable part again, make I equal to 4. 4 is less than 5, so it would check the condition. 4 is less than 5, so do whatever's in the brackets, curly brackets again. Hit the end bracket, do the changing the variable thing again. I would now equals to 5. And then we get to the point where 5 is not less than 5, so it won't be looping anymore. This is false if I is 5, so it would jump to this line and start executing whatever's on this line next. And that's how a for loop works. You can count down, you can do all kinds of stuff. We could start it at 5, keep going while I is greater than or equal to 0, and go make it decrease by 1 each time. Same idea, but counting down. A big thing I tend to do is, like, let's say I've got like 10 LEDs in my project and I don't want to do pin mode with them all. So it might be like in pin equals 2. Let's say I've got pins 2 through 11 and they're all, I want to set them all to be outputs because they're all LEDs. I just say, hey, pin is less than or equal to 11. pin plus plus, so pin's going to equal 2, then it's going to equal 3, then it's going to equal 4, then it's going to equal 5, so then I can then do pin mode pin. This pin's going to be 2, then 3, then 4, then 5, all the way up to 11, and then output. And now I just saved myself 10 lines of code by doing kind of 2 lines. Yeah, so instead of 10 pin modes, I only need the 1 for loop and the 1 pin mode. Because it's just going to do it again and again and again. Once one pin is 2, once one pin is 3, once one pin is 4, once one pin is 5, all the way up to 11. Anyway, hopefully this helps with the coding. Apologies I was not more concise. Thanks for listening.